Just before we start this example, I'm not sure if I formally identified this type of investment system or mentioned the word annuity. So an annuity is when we engage in an investment system where we're going to make regular deposits. So our superannuation is one, or you could just straight out do an investment without it relying on your income and waiting until you retire to claim that, which is the conditions for super. So let's have a look at this example. Oliver's grandparents invested $1,000 in an annuity for him on the day he was born. They continued to invest $1,000 on his birthday each year thereafter until he was 20. On his 21st birthday, they gave him the final amount of the investment. So this is an investment that they're in control of, and they're deciding how much they put in and how long they're going to do this for. So just be careful with this. They say that they made the last deposit on his 20th birthday, but that in fact means that they have already made 21 installments. I think he was born here, so I guess on the timeline he's 0, but that was payment 1. When he was 1 year old, they made it their second payment. When he was 2, they've made their third. When he was 3, they've now made 4 payments. And so we can dot that up to when he's 20, they will have made 21 payments. So it says calculate the amount Oliver receives on his 21st birthday if the annuity earns 7% per annum compounded annually. So this is the familiar formula that we know, compounding. And we're just going to treat initially each investment separately and try to track what that investment is doing. So let's get started with the solution. The first installment would actually be invested for 21 years in full, and it would amount to 1,000 times 1.07 to the 21. Where do these numbers come from? 7% per annum, and 21 years that first investment sat there. The second installment would only be invested for 20 years. So this first one sits there for a full 21 years, but the second one only sits there for 20 years. And it would amount to, and these formulas are just coming from, A is equal to P times 1 plus R to the N, where the P is always $1,000, the rate is staying the same, but the amount of time each installment is invested for keeps decreasing, so we're down to 20. The third installment is invested for 19 years and amounts to 1,000 times, I'll write it as 1.07 now to the 19. So third installment, there for 19 years, etc. The 20th installment is invested for 2 years, and it amounts to 1,000 times 1.07 to the 2. And the 21st installment, the one made on his 20th birthday, only sits there for the 1 year, and it amounts to 1,000 times 1.07, just sitting there for 1 year. Now, we sum these in reverse. So we know that the total amount that is invested is the sum of the 21 amounts. What does that actually look like? that will be the last instalment, the 21st instalment made on his 20th birthday, sat there for just 1 year. The one before that, the 20th instalment, sat there for 2 years. Now, this then continued, back to this is the equivalent of this second instalment, sitting there for 20 years, and the very first instalment sitting there for 21 years. If I was to take out the $1,000, then I would have 1.07 plus 1.07 squared plus 1.07 cubed, up to 1.07 to the 21. Now, hopefully you can see this is the sum of a GP, where A is equal to 1.07, R would be this term over that term, which is 1.07, this term over that term, 1.07. So R is equal to 1.07, and there are in fact 21 terms. So this part of the total amount is the sum of a GP. So it says, using the sum of 21 terms, because there are 21, and the formula, the sum of n terms is A times R to the n minus 1 over R minus 1, and check that back on page 1 if you've forgotten the sum of n terms of a GP. Let's write down what that sum is going to be. And so I've got 1,000, keep your 1,000, then sum your GP using this formula, A times R to the n minus 1 all over R minus 1, and just simplifying that, going to our calculator, and this is where this new calculator really helps. And we get $48,005.73916. Obviously that would be rounded off, the 9 would get cut off, and round the 3 up to a 4. So that's a pretty nice investment, $48,005.74 that Oliver received on his 21st birthday. And this is a much shorter way of doing it than trying to add up 21 different amounts and calculate each one. So hopefully, you've recognised that in summing an annuity or finding out the value of annuity, you really are just dealing with a GP. I just remind you to be careful and read the question really carefully. Not every situation will be like this particular one. You could get something very similar where no payment was made until the first birthday. Now that's going to change it considerably, because if a payment is made on the first birthday, then paid out on the 21st birthday, then it's only sat there for 20 years. And obviously that's going to change the value of the annuity. There may or may not be a payment made on the very last birthday. Now, all those sorts of details must be outlined in the question. It sort of doesn't make sense, but I've seen questions where it happens, where a payment is made, for example, on the 21st birthday, so an additional $1,000 is added in, but it doesn't actually earn any interest. But it has to be added in because the question states that it's actually part of the investment. So read the questions carefully, be prepared to make variations based on this example as is needed by the description of the question.